All right, so because I'm not here in school today, I'm going to give you the notes through this Edpuzzle video. So what you'll do is follow along with this notes sheet. You'll take the notes down yourself as well, and then I'm sending you a homework problem set that you can work on that is related to this page of notes. I'm going to make that homework be due on Wednesday in case there are any questions, and we'll address them tomorrow in class. Okay, so today we're addressing or and because yesterday or on Friday our probability situations were pretty straightforward. It was just the probability of one event happening, and they were pretty individual events. So let's look at this first situation. It says a fair die is rolled. We can find simple probabilities since the sample space contains 1 through 6. Let A represent the event that an even number is rolled, and let B represent the event that a number less than 3 is rolled. Okay, so I'm just going to list the values in our different event spaces here. A is an even number, so that's going to have to be 2, 4, or 6. And B is going to be a number less than 3, so that only leaves us with 1 and 2. Okay. What is the probability of the intersection A and B, which is the event that a number is rolled that is even and is less than 3? Okay, so let's discuss what this intersection is, and we'll make a note of it. So, the probability of an event A and B taking place is the intersection of their events. So it's the intersection of events A and B, and it reads the probability of an element being in A and being in B. All right, so it might be best in this case for us to see this visually. So let's say that we've got our sample space S. So there's S. And then within S, we've got a sample or an event A that can happen. And we've got an event B that can happen, and we need to make note that there is some overlap because 2 is not just in the sample space, not just in A, but it's also in B. The number 1 is in B. The number 3 is only in the sample space. The number 4 is in A, but not B. 5 is in the sample space. And then the number 6 is in A, but not B. So this is sort of a visual representation of what we have going on. Numbers 1 through 6 are all in the sample space. We have some values that are in A, some are in B, and there's one that's even in the overlap of A and B. So when we're looking for the probability of A and B, we need to know how many elements there are in A and B. All right, so we're looking for the event that a number is rolled that is both even and is less than 3. So where are the numbers that are even and are less than 3? Well, a good way to remember that intersections are and where to find them is if you draw a Venn diagram, they are all of the values in the space where the two sections intersect. There is only one element in that sample space. So to continue calculating probabilities the same way that we did in our lesson, we're now going to need to know the number of elements that are in both A and B, divided by the number of elements in the sample space, which as we see here is 1 out of 6. There's only one number that is both even and less than 3. And there are 6 numbers in the sample space of all the numbers on a 6-sided die. All right, so B is asking what is the probability of rolling a number that is both odd and a 4. All right, so if we just think about the elements that would be in this group, well, we've got some odd numbers. We've got 1, 3, and 5. And we have the number 4, but there's no situation where we have a number that's both odd and 4. So that's actually not possible. And we would say that this is the empty, or this is an empty set. So the probability of any event happening when the set of all possible outcomes in that group is an empty set is going to have to be 0. So we'll say, even though it seems sort of like a silly thing to have to write, but we'll say that the probability of a number being both odd and being a 4 is 0. Because the set of all numbers that are both odd and 4 is empty. Okay, so which brings us to the idea of if something can have a probability of 0, well, what is the greatest probability that something could have? And that would actually be the number 1. So we're going to make a note over here that the probability of any impossible event is 0, as we just saw, but the probability of any event that's guaranteed is 1. So all probabilities, or the probability of any event, probability of event E, has to sit somewhere between 1 and 0. And it can be equal to 0 or 1, but it's going to be somewhere in there. We're never going to have a probability that's greater than 1 or less than 0. So we've dealt with the word and now we need to deal with the word or. All right, so we said the intersection of events would be synonymous with the word and we also have something called the union of two events, which would be synonymous with the word or. So let's define the union. So the union of any two events is just the probability that you will find an element that is in group A or is in group B. It's just one small change here. And is very exclusive, and we'll see that or is exclusive in some ways, but not nearly as exclusive as and in most cases. So we'll see a concrete example here. Consider the impact of changing the word and to or in the above scenarios. So these are the same scenarios we had above, but instead of even and less than 3, we're going to start with even or less than 3. So the probability of even or less than 3. Well, the way that we're going to want to calculate this is we're going to want to find all of the values that are either one of these two things, right? It's not going to have to be even and less than 3. It's just got to be even, or it's got to be less than 3, or it could be both, right? So we think of the values that would fall into this group. All right, that would be 1, because although it's not even, it's less than 3. 2 is both even and less than 3, so we'll definitely count that one. 3 is neither. 4 is even though, and 6 is even. So these are all the numbers that are either even or less than 3. So we'll say that there are 4 numbers that are even or less than 3 out of 6, and we could reduce this fraction to 2/3. So when it was and, it was 1/6. When it was or, it was 2/6. And that's often going to be the case, that the union will be a larger value than the intersection, because the intersection is much more exclusive. Let's calculate the probability of a value being odd or a 4. Now when we tried to do odd and a 4, the probability was 0. That was impossible. But when we do odd or a 4, and we think about all the numbers that meet either of these criteria, go up to our set above. 1 is odd, 3 is odd, 4 is 4, and 5 is odd. So there are 4 numbers that are odd or are the number 4 out of 6, which again is 2/3. So another good example where the intersection was very small, actually the smallest it could be, but the union was relatively large, 2/3. Okay, so a lot of the time we won't be able to just see the values sitting here, and there is a formula that goes along with calculating the union of two events that makes life a little easier in those cases. So we're going to write down that formula. We're going to see it used here once, and then we'll do a couple practice problems. So you should write this formula down, and I'm just going to walk through exactly what it's saying here. It's saying if I want to calculate the probability of any union, I can take the probability of the first event, if I know that. I can add it to the probability of the second event, and then I can take away the probability of the intersection of these two events. And we're going to see that used. So if we were to use this with the example that we just saw, right? I wanted to calculate the probability of event A or event B taking place right here. I could have used this formula, which says I just need the probability of event A taking place, which we know, right? We know that the probability of A is 3/6, which I'm not going to simplify just yet, just to make my life a little easier. So the probability of A, which is 3/6, plus the probability of B, which we know to be 2/6, minus the probability of the intersection of A and B. And remember, the intersection of A and B was 1/6. So I could have used this. Now 3 plus 2 is 5 minus 1 is 4 because they all have a common denominator. 2/3. So what this proves is that the formula works because I was able to do it by seeing the numbers and clearly see that the probability of A or B was 2/3, but my formula also shows me the same thing. And I'd get that same result if I tested odd or 4 as well. If I wanted the probability of a number being odd or being a 4, I would take the probability of a number being odd, and 3 of those 6 numbers are odd, plus the probability of a number being 4. There's only one number in that whole group that's a 4, minus the probability of a number being odd and being a 4. And that was an impossible event, right? We found that that is impossible to be both odd and a 4. And so if I add those and subtract 0, I get 4/6 or 2/3. Same thing I got when I saw the values. Okay, let's just do a couple quick practice problems, and then you can start working on the homework problem set. Okay, so we're on the back of the notes here, and we're going to go through all 4 of these. Go ahead and calculate the probability that if a fair die is rolled, you will get a number that is greater than 2 and odd. So here's my calculation. On a 6-sided die, the only numbers I can think of that are both greater than 2 and odd would be 3 and 5. So there are only 2 out of 6 numbers, or 1/3. Hopefully you got that result as well. The second one would be the probability that you get a value that is less than 4 and is greater than 3. Go ahead and calculate that probability. Okay, all of the numbers that are less than 4 and are greater than 3, that is impossible. There are no numbers that are less than 4 and greater than 3 on a 6-sided die. So that is an impossible event. 0. Greater than 2 or even. You could probably do this just by counting up the numbers that you know that are greater than 2 or even. I'm going to do this using that formula, the union formula. So I'm going to say to calculate this, I need to know the probability that a number is greater than 2. I'll add that to the probability that a number is even. And I'll just take away the probability that a number is greater than 2 and even. So the probability that a number is greater than 2 would be 4/6. That's 3, 4, 5, and 6. The probability that a number is even is 3/6. And all of the numbers that are greater than 2 and are even, that would just be 4 and 6. So 2 numbers. So when I add 4 plus 3, I get 7, minus 2 is 5. 5/6, which you could have done just by counting up those values. But you can imagine that right now, since we're only working with small numbers of values, there are only 6 numbers on a 6-sided die, it's pretty easy to do. But if these numbers were getting larger and larger, a formula might be necessary in order to handle larger amounts of data. Okay, last one. Probability that a number is prime or is odd. Okay, the probability that a number is prime plus the probability that a number is odd minus the probability that a number is both prime and odd. Prime numbers on a 6-sided die, there are 3. It's just 2, 3, and 5. Odd numbers on a 6-sided die, and prime numbers that are also odd, that's just going to be 3 and 5. So that would be 4/6 or 2/3.